To understand how matter changes, we can look at the foundation laid out in standard science texts. Think about milk turning sour on the kitchen counter, or raw eggs solidifying in a hot pan. These everyday occurrences are actually hidden chemical events happening right in front of us. The rule for spotting one is simple. Whenever the core identity of a substance changes into something completely new, a chemical reaction has taken place. We are constantly surrounded by these unseen shifts. But while cooking an egg is quiet and predictable, some of these chemical changes are incredibly violent. For example, imagine trying to boil a pot of cold water without using a stove, electricity, or any kind of flame. To test this, all we need is a normal glass beaker filled with room-temperature water and a chunk of dry white rock known as quicklime. If you drop that rock into the water, the glass erupts into a violent hissing fit of steam. Looking at this thermal simulation, you can see the normal view on the left, but on the right, the water glows deep red as the temperature spikes well past the boiling point. Since there is no burner underneath the glass, where exactly is all this sudden, massive heat energy coming from? This intense energy radiates from a microscopic collision happening deep within the water itself. To see how that heat is created, we have to look past the visible splashing and zoom all the way down to the level of individual molecules. This animated diagram shows our starting ingredients, a molecule of calcium oxide floating separately from a molecule of water. When they collide, they don't bounce off. They chemically lock together to form a single structure called slaked lime. We can write this physical fusion as a chemical equation. Notice how the two separate starting ingredients on the left combine to produce exact one final product on the right. Scientists have a specific name for this event. Whenever multiple substances fuse to form a single new product, it is called a combination reaction. The combination equation explains how the slaked lime is made, but it still doesn't explain the fireless boiling. The boiling happens because this specific combination is what chemists call exothermic. Exo meaning outside, and thermic meaning heat. Before they collided, the separate molecules of quicklime and water were holding on to a high amount of pent-up unstable energy. In this diagram of the new molecule, you can see that as it locks into a tight, stable configuration, it is forced to violently eject all that leftover, unneeded energy directly into the water. This surge of heat is the physical byproduct of atoms finally finding a comfortable, stable arrangement. This reaction is highly useful outside the laboratory. Long before modern chemical factories existed, humans had to figure out how to paint their buildings bright white.
The practical secret is that the hot, watery, slaked lime left over in our beaker is actually the main ingredient for traditional whitewash paint. By dropping quicklime into buckets of water and letting the violent mixture cool down, tradesmen created a thick paste they could safely brush right onto the rough walls of their homes. For centuries, everyday workers were actively wielding complex heat-releasing combination reactions just to do basic home improvement. Once the slaked lime is applied to the wall, the chemical journey continues. A second, much slower reaction begins immediately. As the wet slaked lime sits exposed, it starts interacting with invisible carbon dioxide gas naturally floating in the surrounding air. This cross-section shows the wet layer on the wall actively absorbing those carbon dioxide particles, slowly transforming into calcium carbonate, a solid, shiny white crust that protects the building. The entire process starts with a violent, heat-releasing combination in a bucket and finishes with a slow, hardening polish on a wall. Some of the most beautiful, enduring architectural finishes in human history are simply the practical result of invisible molecular matchmaking.